Good morning, Year 10. We are looking at alternating current today, cables and plugs. So for you budding electricians out there, listen up. For you homeowners, listen up as well, because at some point you are going to have to fix your own plug. Title today is on the screen. Write it down. So we have two types of current: direct, goes in one direction, and alternating, which means it goes back and forward. So most mains in the UK are alternating current. The mains in the UK for electricity is 230 volts. And when we use DC, direct current, that is just for things like batteries and cells. So normally we are using mains electricity, which is alternating current, which is what we are looking at today. So what I want you to do, I want you to write down in your books that DC is direct current and AC is alternating current. And then I just want you to add that the AC current in the UK is 230 volts. So on the screen, you've got oscilloscopes showing both types of current. Here we have a graph from an oscilloscope showing the signals from our main supply. We have our potential difference showing a large variation between a positive and negative value, giving this wave effect. This is shown in red and represents our brown live wire. Remember that, brown live wire. Then we have our blue neutral wire. Remember that as well, because you're going to need that in a minute. So the blue neutral wire shows the voltage, which is almost close to the earth, which is 0. And the earth is normally yellow and green. Now, if you look here at our red wavy line, you will see there would be a mean or an average voltage of our mains of around 230 volts. You need to know that off by heart, that the main supply in your household, so our electricity supply, is carried at 230 volts. Other countries may have a different voltage, but in the UK, our mains, our electricity supply is served to us at 230 volts. As you can see from this oscilloscope graph, the peak actually goes higher than that. It actually goes slightly over 300 volts, but the average, like I said, is 230. So I want you to make a little note of that in your books. What we also need to know is the frequency of our electricity supply, and our electricity has a frequency of 50 hertz. Symbol for that is capital H small z, which means basically that it changes direction 50 times a second. Incredible speed. That is why it is an alternating current, because it changes direction. Now, if we want to work out what the frequency is, what we need to do is measure the time for a period of a wave. So basically the periodic time, so how long it takes to go up and down. We then do 1 divided by that time, and that will give us the frequency. So I want you to note down in your books the equation for frequency, and then put a note that the frequency in the UK is 50 hertz, meaning it's 50 times per second. Okay, got a research task for you now. I want you to label this plug in your books, find out what a fuse is, and find out what an earth is. If you've been listening, you will already know what the 3 different coloured wires are. I've also added some extra information here for you budding electricians and scientists, and all of you aiming for those 6, 7, 8 and 9 grades, which you should all be doing. So you should have labelled your plug with a neutral wire, which is the blue one, a live wire, which was brown, and the green and yellow was the earth, as shown in this picture here. So what is the earth for? The earth is basically to stop you getting an electric shock. So write that down. So pause the video now and just have a little look at the different types of earths you can get here. So you've obviously got an earth on a washing machine here connected to the metal casing rather than the electric shock going through you. You've got the earth for your house on the right hand side here. So every house will be earthed as well. So somewhere in your house you will have this green and yellow wire connected to the floor again, so the shock, if anything goes wrong, is not going through you, it's going through to the ground. And then if you have an appliance that is actually plastic, you do not need the earth to be attached to the casing. So now we know about electricity, we also need to know about how that electricity is delivered to our houses. And it is delivered by a system called the national grid. So that basically involves all the network of cables, step up, step down transformers that transport electricity from power station to everywhere. Shops, factories, schools, homes, basically anywhere that needs electricity relies on the national grid. Can you please in your books write a definition for this term? Here we have 6 pictures which enable electricity to flow into our houses. So I want you to read the information here and then work out what the order is for these 6 pictures. So the electricity is carried around the country to our homes and offices via pylons and cables. To do this, we need to reduce the amount of energy wasted. So basically, we use the equation power equals current times by voltage. And what happens actually is the voltage is upped, so it's very, very high. This makes the current very low. If the current is low, less energy is wasted. So what I want you to do, I want you to take this information on the screen and I want you to bullet point this into as few words and sentences as you possibly can. Make it short and sweet. So here we have a detailed picture of our national grid. So we start off with our power station. That basically generates electricity. It could be from nuclear energy, it could be from coal, oil, gas. That energy is then stepped up. So basically, as it comes out the power station, it needs to be upped to stop it from losing too much energy as it's carried to our houses. So it's stepped up to like 240,000 to 400,000 volts. Those volts are carried on long overhead cables, which are held up in the air by electric pylons. Then as it gets to wherever we need it, that could be office, home, school, it needs to be stepped down again, because if you have this kind of high voltage coming into your house, it will literally blow everything up. So it needs to be stepped down to a normal level. So in the UK, we use 230 volts, and then obviously it's sent on to the consumer. So what I want you to do, I want you to sketch this diagram in your books, and I will give you some more information on why we step up and step down the electricity. So what I want you to do here is just add a little note from this information to your diagram, just to add a bit of clarity. Right, I want you to draw this table in your books. We are going to look at 2 advantages and 2 disadvantages of overhead cables and underground cables. So once you've drawn this, I want you to look at the next 2 slides and pick 2 for each different type of cable. Off you go. Just to finish off our lesson today, we have a correctly labelled picture of a plug and the answers to why we need a fuse and an earth. Just remember, when dealing with electricity, we need to know the safety features, which are fuses, earths, cable insulators, cable grips, plastic coverings. We also need to know that our electricity is carried on high pylons and cables because obviously when it's running at a voltage of 400,000, it needs to be well away from humans and activity on the ground. So that brings us to an end for this lesson. Just go through and just add in the information you're missing from this slide. Thanks everyone. Bye.